In this video, we will be modeling linear time trend in EViews. The data series that I will be using is US retail sales. We have US retail sales from 1954 to 1995. We will split this data into two parts. So the entire data series, or the entire time frame, is from 1954 January to 1995 January. And then some part of this data, so till 1992 December, we'll be using that for fitting the model, sort of training the forecast model, your in-sample. So this is our in-sample model fitting. And then from 1993 January to 1995 January, this data we are going to be using for model evaluation. So this will serve us as our out of sample. And then finally 1995 January to 1996 December will be our forecast period. So this, we don't have data to compare that forecast, so the comparison will be done with the out of sample. So here's the series going from 1954 all the way to 1995 January. Always a good idea to plot the data across time to see what the pattern looks like. We can see that it has been going up over time. There's a slight curvature, probably not a linear trend, but we will start with a linear trend, do some model comparison to see which one is the best. I'm increasing the range of the data to 1996 December to fit the forecast horizon, or the forecast period as well. Continue. So you do this just by double clicking on the range. So now you can see that the sample and range has changed till 1996 December. Let's create the time series. So a series for time. So time, this could be time, t, whatever you want to call it, trend. Time is equal to @trend. EViews does not care for space, so don't put space before or after the equal to sign. Okay. So this has generated a variable that is 0, 1, 2, 3, 4, 5, 6, 7, and so on across the time frame that we have. Now let's estimate the linear trend, estimate equation, dependent variable. So the sample size over here, I am changing this till 1992 December, because that will serve as the in-sample model, the estimation period. You can see over here, so the in-sample is from 1954 to 1992 December. Okay, now we can write the equation RTRR, dependent variables, C for constant, and then time for that linear trend. Okay, there we go. There is your model for a linear trend. You can see the coefficient for time and other key statistics down here. We're going to go back and refer to this. Let's go to the residuals to see how the model is doing. The straight line over here, that's our fitted. The curved line, a little bit, the red one is the actual, and the blue line over here is the residuals. Looks like there is still a slight pattern in the residuals. Moving on to forecast. At this point, you can name the series your forecast series, or you can wait till you save the entire one. Here the forecast sample will just be till 1992 December, because this is used for in-sample, very like in-sample sort of model evaluation first, to see how the model worked, the forecast model worked within the training data in the estimation period. Uncheck the insert actuals box and then graph forecast and actuals. Okay, there we go. The straight line over here, that's the linear trend. The green line is the actual data, and then the red lines are the forecast intervals, or the prediction intervals. Okay. The statistic that is important for us over here is the root mean squared error. We are going to take a note of this. So record the in-sample root mean squared error 15819.21. Okay. Let's look at other important statistics. Let's go back to stats and then keep a record of the adjusted R-squared. Copy, paste. AIC, copy, paste, and then SIC with the linear trend model. Copy, paste. Okay, we have the adjusted R-squared, AIC, SIC, and our in-sample root mean squared error. Let's go back to forecast, and this time uncheck the insert actual for out of sample. This time we're going to be forecasting from 1993 January till let's go back and check what the out of sample range was. 1993 January to 1995 January. So 1995 January. Okay, graph, forecast, and actual, and then okay. Alright, so the green line over here, the solid line, blue line is the forecast, the green is the actual data, and then the dotted lines are the forecast intervals. So now we have the out of sample root mean squared error. So we'll save that. So 37987.64. You can see the out of sample error is much larger than the in sample, even though the data is smaller. The data size. Okay, let's go back and forecast again. This time we're going to be forecasting for the entire range, including the forecast period. So keep that box checked, forecast and actual. So here we go. We have all the data points till 1995 January. That's the actual data set. The solid straight blue line, that is the forecast, and the dotted ones are your forecast intervals. Okay, we cannot use the root mean squared errors from here because this was not computed using 1995 to 1996 data. Okay, I'll name this graph linear graph because it's just nice to have this and to go back and refer to it. Again, EViews does not care for space. So use something else in place of space when you're saving names and objects. And then display name, this is what will show up in graphs. So retail, sales, linear forecast, linear trend forecast. Okay. Let's go ahead and save our equation. So back to the equation window, so name. And then I'll name this just linear equation underscore EQ. Okay, this way you don't have to go back and then create the equation every time. Now you know how to model linear trend in EViews.